Have you ever wondered why an apple falls from a tree, or why the stars twinkle? Welcome to the fascinating world of physics, an essential science that is quietly at work in every moment of our lives. Physics is the study of matter and energy, and the intriguing dance they perform together. It's the subtle whisper in the wind, the vibrant echo of a crashing wave, and the silent pull of gravity that roots us to the earth. Physics is the fundamental science, the cornerstone upon which all other sciences are built. It explains the principles that govern the natural world, from the tiniest particles to the vastness of the universe. It's the science that tells us why we don't float off into space, why the sun rises and sets, and why that apple falls straight down from the tree. So next time you see an apple fall, you know there's more to it than meets the eye.
Ever heard of a man named Isaac Newton? This 17th century scientist gave us 3 fundamental laws of motion that help us understand the world around us. First up, Newton's first law, also known as the law of inertia. This law tells us that an object at rest will stay at rest, and an object in motion will stay in motion, unless acted upon by an outside force. Imagine you're kicking a soccer ball. It wouldn't move unless you, the outside force, kick it. Next, Newton's second law. This one's about force and acceleration. Simply put, the harder you kick the ball, the faster it will go. Finally, Newton's third law. This law states that for every action, there's an equal and opposite reaction. So when you kick the ball, your foot feels a bit of a kickback, doesn't it? These laws govern everything from the rotation of planets to the flight of a football. Remember, every action has an equal and opposite reaction, even in physics. Let's talk about energy. What is it, really? In simple terms, energy is the capacity to do work. It's what powers everything in the universe, from your morning cup of coffee to the stars in the night sky. There are many different forms of energy. For instance, when you throw a ball, it has kinetic energy, the energy of motion. But before you throw it, when it's in your hand, it has potential energy, energy stored due to its position or state. And then there's thermal energy, which is the total energy of all the microscopic particles in an object. It's what makes your cup of coffee hot and your ice cream cold. But here's the kicker. Energy can neither be created nor destroyed. It can only change forms. This is known as the law of conservation of energy. So when you're sipping your hot coffee, you're not consuming energy, you're just transferring it. So energy is never lost, just transformed. That's the beauty of physics. Now, what if I told you gravity is not just a force, but a curve? Yes, you heard it right, a curve. This idea comes from none other than the brilliant mind of Albert Einstein and his theory of relativity. Einstein suggested that what we perceive as the force of gravity is, in fact, the curvature of space and time. To make this easier to understand, imagine a trampoline with a heavy bowling ball in the middle. The bowling ball distorts the trampoline, creating a dip around it. Now, if we roll a smaller ball onto the trampoline, it will naturally move towards the bowling ball. Not because of a mysterious force pulling it, but because the path it follows is shaped by the dip the bowling ball created. In this analogy, the trampoline represents space-time, the fabric of our universe, while the bowling ball symbolizes a massive object like the Earth. The smaller ball is anything affected by the Earth's gravity, like an apple falling from a tree, or even us. Now, this curvature doesn't just affect the path objects take, but it also influences the flow of time. Yes, gravity can slow down time. This is another mind-boggling prediction of Einstein's theory. The closer we are to a massive object, the slower time moves. This effect, although incredibly minute on Earth, has been confirmed by precise timekeeping devices known as atomic clocks. So, in essence, gravity is more than a simple pull. It's a fundamental interaction that shapes space and time, guiding the motion of everything from tiny particles to massive galaxies. And while it keeps us firmly grounded on our planet, it also reaches out into the cosmos, bending the path of light from distant stars and shaping the large-scale structure of the universe. Gravity, the force that keeps us grounded and shapes the universe. Fascinating, isn't it? So, what have we learned today? We've explored the essence of physics, the science that describes the fundamental workings of our universe. We've delved into the laws of motion that govern everything from a falling apple to a soaring rocket. We've grasped the concept of energy, the driving force behind all phenomena. We've also journeyed through the intriguing world of gravity and space-time. Physics, the science of the universe, always there, waiting to be discovered. Until next time, stay curious.